I think we can begin. Welcome to the second in the new Haddin Forum series. We're having these talks, discussions, presentations generally on the last Friday of every month. So that gives you a kind of a fixed date to think of. I'm Kieran Quinlan from the English department. I'm the director of the forum, but this last year, Dr. Rebecca Bach has really done the heavy work there. Today we have, I suppose, kind of the ideal speaker for a forum like this in Dr. Jim McClintock, who is the university professor of polar and marine biology here at UAB. In a recent piece in the Birmingham News, Joey Kennedy called him, this will probably embarrass him, but he called him a rock star in the polar and marine biology world. But really, with the new book, he's a rock star in a much wider world. And the book has been partly encouraged by entomologist E.O. Wilson from Alabama fame, or Alabama background, at least I suppose I should say. And no less than Al Gore and Bill Gates have also commended it. And I think you probably, since Jim is a rock star, you don't need any more of a warm-up, or should I say a cooling down. So, thank you.
Maybe I can get somebody to get the lights down as much as possible. That would be great. So it's wonderful to be here. Figure out how I'm going to do my slides. Do you figure out the lights? Rebecca, do you know where they are? Maybe you have to hold. No, they're perfect. Okay. So I thought a little bit about the arts and the sciences in this, and so today I'm going to actually combine a little bit of both. And I need to recognize right off the bat that soon after we became a college, I met a wonderful English professor, Adam Vines, who has recently become part of our tenure faculty here, who worked with me on this book. I needed somebody who could bring the editorial English piece to the table. So I want to acknowledge his contributions in that regard right up front. So I want to start by, I'm going to talk today about the science, the ecology, the impacts of climate change. But I also want to give you a touch of my book. And I'm going to do a little reading for you. This was my first dive below the sea ice in Antarctica. The picture actually is not me. It's actually a picture you can see the diver silhouetted in the back there. That's Chuck Emsler in our Department of Biology here, who's diving under the ice. But this was sort of the same type of image that I saw. Across the seafloor, peach-colored soft corals spread out amidst cream-tinted sponges which stood 3 or 4 feet tall like ancient Venetian vases. Giant marine worms and 12-inch diameter sea spiders added an element of absurdity to the landscape, and bright red sea urchins carpeted the seafloor, and red and yellow starfish nestled among them, feeding on sponges. Among the soft sediments resided fields of clams and snails, while shelled brachiopods and bushy colonies of bryozoans attached to the exposed hard surfaces. I was drifting, as if below the ceiling of a magnificent building whose floor lay 80 feet below me. I was struck by the same sense of awe one experiences entering the Sistine Chapel, only instead of Michelangelo's paintings, I was gazing at a ceiling aglow and adorned with intricate platelets of ice. So that was my first dive, and I dove in Antarctica my first dive was 30 years ago in Antarctica now, and I've been working down there over 14 different expeditions. And over the past, particularly over the past 15 years, since our research program has moved from the McMurdo Station on the Ross Sea up to the Antarctic Peninsula at Palmer Station, The Antarctic Peninsula is about a 1,000-mile-long peninsula that extends up under South America. There has been a tremendous impact of a warming climate on this environment, and that's what I want to share with you. You've probably seen things like this. This is out of National Geographic, and you always think of the Arctic as the area that's warming so dramatically. It seems to get most of the press. But actually, even back in 2006, you see areas that have been warming on the Antarctic Peninsula. And in fact, in a more recent study, on the cover of Nature magazine, there is now data that indicates that the entire western reaches of the Antarctic continent, and this is the size of India and China combined, are beginning to warm as well, in addition to the peninsula. So far, the eastern side of Antarctica is not warming. Well, the area that we're working is right here, about halfway down the length of this 1,000-mile-long peninsula, a little station comprised of 44 people. About half of them are scientists, about half of them are support personnel. And we get there by flying down to the southern tip of South America and getting on a ship. And you can read about the wonderful experiences I've had crossing the most infamous body of water on the planet, the Drake Passage. Sometimes it's Lake Drake, 3 days of nothing but calm. And one time I came back in the early winter and woke up midair, thrown from my bunk in 40-foot seas. So it can be exciting at times, particularly in the winter. Well, very fortunate to us, about 20 miles down the coast from Palmer Station is another station. It's a British station originally called Faraday. It's now called Vernadsky. And for 60 years they've been recording air temperatures. And we have a good record now that would indicate that this portion of the peninsula here on the western side has been warming about 1 degree centigrade a decade, or 10 degrees Fahrenheit over the last 60 years. This makes the Antarctic Peninsula the most rapidly warming region of our planet, even more than the Arctic, which had a record low sea ice this year, as you've been reading in the papers. So, how do you sense that? How do you know that if you visit the peninsula? Well, I can tell you from personal experience that 13 years ago, when I used to be sitting at my desk at Palmer Station, once or twice a week, there would be a tremendous explosion. You'd leap up from your desk, everybody would come cramming down the hall, open the door, look out into Hero Inlet, and there'd be a big chunk of the Mar Glacier breaking off into the bay, and waves coming down the bay. This last year when I was at Palmer Station, a little over a year ago, this was happening 4, 5, 6 times a day. People didn't get up. They just, there goes the glacier. So this is happening all up and down the western side of the peninsula now. 87% of the glaciers on the Antarctic Peninsula are displaying recession. They are breaking up and melting and crashing into the sea. Now we know this a little more quantitatively because we have people like this science technician who's got his backpack on. He has an antenna sticking out of his backpack that's talking to a satellite over his head. And using GPS, he walks the leading edge of the glacier every year so that we can map it. And you can look at the Mar Glacier over a period of quite some time and see that back when Maggie Emser, who's my research associate in the biology department, used to go to Palmer Station in the 70s, she said you could almost open the door of the station and step out on the glacier. It was that close. And now it's a 1/3 of a mile hike to get up to the edge of the glacier. So we know that this is a very rapid recession. The other thing that's happening all up and down the Antarctic Peninsula now is that ice sheets are breaking up and going out. Now ice sheets are a little different than glaciers. They're not sitting on the land. The ice sheets I'm talking about are on top of the ocean, and they are right along the coastline. And there have been 8 major ice sheets that have broken out in the last 30 years. And I just want to highlight 2 of them, the Larsen Ice Shelf here, and also we'll talk about the Wilkins. So we're going to go over around the corner on the eastern side of the peninsula where it's supposed to be a little colder. And on January 31st, a satellite flew over the Larsen B Ice Shelf and noticed, scientists noticed these striations going on in the ice shelf. A month later, the entire Larsen B Ice Shelf began to completely disintegrate. And by 2 weeks later, it had completely disintegrated. So it's hard to tell because everything is relative here, but this is actually a big chunk of real estate. This is 5,700 square kilometers of ice. This is the size of Rhode Island that just broke up and went out to sea over a period of a few weeks. More recently, you may have read in the newspapers a couple years ago, way down here at the base of the peninsula, the Wilkins Ice Shelf indicated that there was disintegration going on with satellite images. Now, fortunately, so far, the entire Wilkins Ice Shelf has not gone out. It's dangling by a thread of ice, literally. And probably within the next few years it will. And when the Wilkins Ice Shelf goes out to sea, that's a piece of real estate the size of Connecticut. So these are very large bodies of ice. The good news is that ice shelves, when they melt, do not contribute to sea level rise. This is because they're sitting on top of the water, just like if you have a glass of water with ice cubes. If the ice cubes melt, the water doesn't come over the top. The bad news, though, or concerning news, is that these ice sheets act as barriers for glaciers that are land-bound, that are flowing into the sea. And so these glaciers actually have been recorded to accelerate once these ice sheets are breaking out. And that ice does contribute to global sea level rise. And the interesting thing is, in the last IPCC report, this body of scientists who make predictions about climate change, they chose not to consider Antarctica and Greenland in their sea level rise predictions. And the next one that's coming out in 2014, they're going to. And I think you're going to be surprised at how much higher the predictions are for global sea level rise when Antarctica and Greenland are thrown into that equation. This is the Pine Island Glacier, way down here on the western portion of the continent. I just show it briefly because they're noticing that this is where this entire ice sheet sort of comes rolling out towards the ocean, and there's been a tremendous amount of melt going on underneath the glacier, on the underside of it, that seems to be accelerating that flow. And this has all been happening over the past several decades. And then another image that shows areas where glaciers are thinning. And you can see the red and yellow areas here where thinning is occurring, and also all around Greenland. So lots of evidence, lots of physical evidence in the ice, in the glaciers, in the sea ice, that warming is going on, and very rapidly. But as an ecologist, I'm interested in how these physical changes are interplaying with the biological. How are the organisms being affected by these changes in the ice, by the warming temperatures, by the phenomena of ocean acidification, which I'll talk about a little bit briefly later. We're very fortunate that Bill Fraser, in this image here, decided as a graduate student 38 years ago to start studying the Adelie Penguins in the region of the station. And Bill now has this incredible database where he knows the penguins, how many chicks they've had, how many eggs they've had. He's been following these populations for this long period of time. And Bill's been very concerned because the Adelie penguins are disappearing. And what he's finding is really rather dramatic. If you look at a plot of the penguins, and we have data here in purple for the Adelie penguin, when Bill first started his graduate studies back in the 1970s, there were 15,000 breeding pairs of Adelie penguins on the neighboring islands near the station. The population has plummeted, and I could extend this out to 2012. There's now only about 2,000 breeding pairs left, so about an 80% decline in the Adelie penguin. That's the little guy that looks like Charlie Chaplin up in the corner there. Interestingly, penguins that aren't supposed to be here because they're warmer species, the gentoo and the chinstrap, are moving in. They're moving down the peninsula as it's warming. They're more of a sub-Antarctic penguin. So in the 70s, notice the scale is much smaller over here. A small population of chinstraps, about 200 of them now, 200 breeding pairs are now established near the station. And more recently, in the 90s, the gentoo, this one here, showed up. And now there's about 1,000, actually it's a little bit more now, breeding pairs of gentoos that are found here as well. So you have species that are extending their range into the area that normally were in warmer areas as the peninsula is warming. But the story, let's go back to the Adelie for a minute. All right, so here's my chance to read another little passage from Lost Antarctica. The wind calmed beneath the overcast sky, under which the first snowflake gently fluttered earthward on this late spring day. Knowing instinctively that her chicks were close to hatching, the Adelie vigilantly covered her eggs as the snowfall began to accumulate. At first, only a thin white veil covered the rocky terrain, and later, as the evening light diminished, the snow formed a dense carpet over the entire nesting ground. Dawn revealed a haunting scene on this minuscule island. The penguin still nested, although she was completely buried in snow, with only a small opening from which to breathe. Sadly, her 2 unborn chicks would eventually inevitably drown in the meltwater of this unseasonable snowstorm. A storm fueled by an increasingly moist and warming climate. Each fated chick became a metaphor for the potentially cataclysmic juxtaposition of climate-related events now gathering force over the Antarctic Peninsula. So what's happening is, ironically, as the air is warming, it's becoming more moist and humid. So snowstorms are coming later than they had in previous years. And the Adelies are genetically hardwired to come and lay their eggs at the same time every year. And then they get covered by these unseasonable snowstorms, and they lose an entire generation at a time. So that's one of the reasons why the Adelie, Bill Fraser believes, is having trouble. Another reason is the annual sea ice. As you probably know, Antarctica doubles in size every year during the winter because of the annual sea ice that forms around the continent. The peninsula is no exception. The difference on the peninsula is that temperatures are warming so rapidly that 40% of the annual sea ice is no longer present. And that's in terms of how long it's there during the year and the distance that it extends offshore. And it turns out that Adelies are very closely tied to the sea ice. They depend on the annual sea ice as a platform to toboggan across and get out to the areas where they're feeding on krill, their primary source of nutrition. So because it's much further to get out to these areas where they feed, Bill believes there's an energetic cost for the penguins that's translated into fewer chicks successfully being reared. One other thing that you have to take into consideration that's happening along the peninsula right now is that as the annual sea ice goes, so goes the krill. It turns out that about 20 years ago, krill biologists discovered that when krill are teenagers, they live under the sea ice, and they live in the interstices of the ice feeding on diatoms, little tiny plant cells. And here you can see a school of these juvenile krill. So as the sea ice is being depleted, populations of krill along the northern reaches of the western peninsula are disappearing. And that puts another additional burden on penguins, seals, whales, everything that depends on krill. So the things that do depend on the sea ice are vulnerable. Things like this seal. This is a Weddell seal. Beautiful animal. I love these guys. They have the most amazing adaptation. They have ice chipping teeth. And the female can find a weak place in the sea ice when it's time to have her pup, and she can chip away at it with her teeth until she has a little breathing hole and take her time, and eventually she'll chip a hole large enough that she can slide right up onto the sea ice and pup right there. The beauty of this is that the predators that she needs to worry about, the leopard seals, the killer whales that are out along the ice edge, cannot get to them. She's completely isolated from the predators, and all because of her dentition. There's a little downside in that she doesn't live as long as her mate, because eventually those teeth get so worn down that she ultimately starves because of that. But it does help her when it's time to have her pups. So Weddell seals are becoming more scarce as the sea ice is being depleted. Weddell seals are perfectly capable of moving to other places. It's not that they're disappearing in that sense. Unfortunately, the Adelie is disappearing. The tagging studies that have been done would show that they're not moving. They're actually disappearing. A friend of mine, Hugh Ducklow, from the LTER, the Long-Term Ecological Research Program, is a sort of an oceanographer type guy. He works on bacteria, plankton, and phytoplankton. And I just want to briefly tell you what he's found. In a paper published in Science about a year or two ago, what they discovered is if you look at the northern and the southern portions of the peninsula and compare 2-year periods, the 70s to 80s with the 90s up to the 2006, the weather's changing all up and down the peninsula. It's going from a polar dry climate to a warm, humid, sub-Antarctic type of climate. And that's having huge implications on local weather patterns. For example, it's getting windier up here on the northern part of the peninsula. Well, what does that mean for the marine life? It means that the ocean is mixing deeper, and that plankton, phytoplankton that depend on light for photosynthesis, are being driven deeper and having trouble. The larger plankton are being replaced by smaller plankton. And unfortunately, little jelly-like walnut-sized animals called salps are becoming very abundant on the northern part of the western peninsula. These tunicates are like replacing steak with lettuce. Krill are wonderful to eat. Salps are 90%, 98% water. So it's not a good exchange. Further down the peninsula, things haven't changed quite as much, but the weather is being impacted. The plankton are still fairly abundant, and so far the krill as well. But Hugh thinks that it's only a matter of time until what's going on up in the northern peninsula begins to happen further south. Now, Chuck Amsler and I, in our UAB Antarctic program, have spent a lot of time doing work with plant communities. Plants are not going to be immune. Algae that live in the ocean are not going to be immune to climate changes along the peninsula. They might benefit. As the sea ice recedes, there's going to be more light. I would predict that these underwater forests are going to extend deeper and further down the peninsula as it becomes devoid of annual sea ice. But there could be some other implications. These plants produce toxic chemicals that we've studied to protect themselves. And maybe with more light energy, more photosynthesis, they might produce more defensive chemistry, which could alter the organisms capable of feeding on them, which could alter the whole community structure. So there are implications beyond just simply growth. The other thing I worked on quite a bit as a postdoctoral fellow when I was at the University of California at Santa Cruz was looking at Antarctic marine invertebrates and their babies, their larvae. And one of the things that's so notable about Antarctic marine invertebrates is that because the seawater temperature has been very constant and very low for so many millions of years, they're incredibly sensitive to small increases in temperature. You can take these larvae and raise the temperature 1 or 2 degrees, and instead of developing over 4 or 5 months, like they typically do, they'll develop in 4 or 5 weeks, okay? So you might ask yourself, well, who cares? Isn't that a good thing? The problem is that many of these larvae develop a feeding stage where they depend on the plankton blooms to feed them. So you're at risk here that you might show up at the cafeteria and the door's not open yet because you're offset from these types of events. The other thing is some of these marine invertebrates may just simply not be able to survive small increases in temperature. I think some are, but some are not. So this is just a graph to show how sensitive Antarctic species, this group of clustered little points here, are compared to temperate and tropical species. You change the temperature a tiny little bit, and it has a huge influence on the rate of their development. Species range extensions. Well, I already gave you an example of 2, right? What were the 2 species that were extending their range? The 2 kinds of penguins, right? 15 years ago, the chances of opening the door at Palmer Station and tripping over a 2,000-pound male elephant seal as you stepped out onto the ground was very low, okay? That happens now, okay? Elephant seals that are sub-Antarctic have moved in down the peninsula and established breeding colonies. There's actually a very robust colony now where pups are born every year. The Antarctic fur seal is also showing up. They're not supposed to be there. They're further to the north. They haven't established breeding colonies yet, but it's probably only a matter of time. So these are range extensions. These are things that we're seeing happen in the Arctic, in the Antarctic, all over the place now, even here in Alabama.
So Jim,
Yeah.
what do they eat? Well, I mean, they have to find food, right, to extend their range.
Oh, what do they eat? These guys are eating deep water fish, okay? These guys are feeding on krill and fish. So, yeah. So they're not quite so dependent on krill. They're more fish eaters on average. So I don't think food's an issue. I think they're perfectly capable of moving into these areas. Now, are they competing with other species that are more polar and cold? Possibly. And then there's other implications. Like one of the biologists is very concerned. He studies these mosses in Antarctica that are the beautiful mosses that grow, lichens and mosses that grow on the little islands. And it turns out that these guys are showing up, and this is a protected island because of the mosses. And they're just tromping them all to bits. So there's other sort of implications. The British have actually requested permission to euthanize fur seals because they're so worried about their impacts on some of these protected areas, which raises all sorts of interesting ethical issues. All right, so probably the most dramatic potential range extension that's happening is this one. And I want to set the stage, and I'm involved in this in my own NSF research program in Antarctica. So for 30 million years, the Antarctic seafloor has been isolated from the rest of the world. When the Antarctic Circumpolar was set up, the world's largest current that circles in a clockwise direction around the continent by the migration of South America away to the north of Antarctica, it isolated Antarctica. And the marine life either survived, adapted, or went extinct. And so that means that a lot of the species in Antarctica are only found there. They're primarily endemic species. Some things didn't survive in Antarctica as it cooled. There are no sharks in Antarctica. There are no fish that have crushing jaws. All the fish in Antarctica have very weak jaws. There are no crabs with claws that crush. There are no lobsters. There's nothing with a claw in Antarctica. There are no crushing predators in Antarctica, and there haven't been for millions of years. So maybe it's not too surprising that if I handed you an Antarctic clam, you could crush it with 2 fingers. The shell's wafer thin. Okay? If I handed you an Antarctic snail, you could crunch the shell in your hand. Okay? Now that might be in part because it's a little harder to calcify at low temperature, but I think a lot of it has to do with the fact that there aren't any predators. They've never had to evolve thick shells. So that kind of sets the stage for the observation that my colleague made, Sven Thatchi, who in January of 2007 was sitting in a ship 3,000 or 3,000 feet, 1,123 meters above the seafloor. He was flying a remote operated vehicle along the Antarctic slope. So the Antarctic continent has a slope that comes up and then a shelf underwater before it meets the shore. So he's on the slope. He knows that there has never, ever been a king crab discovered on the slope of Antarctica. And he comes across 13 king crabs that are marching up the slope. So he grabs one of them, does some studies, figures out who it is, and thus was born this hypothesis that as climate is changing, the proverbial curtain that has held out king crabs from the deep water surrounding Antarctica for millions of years is being raised. And we went on this expedition funded by the NSF. Oh, this is another discovery that was made more recently of king crabs, a population of 1.6 million of them within 10 miles of Palmer Station. So we went on this cruise. Grad students, postdocs, a whole bunch of scientists for 9 weeks. And our UAB team and Rich Aronson's team from Florida were given a week of research aboard the ship to run a submarine up transects of the Antarctic slope. We ran about 8 transects. We covered 100 miles of the seafloor in these transects. Took a picture every 3 seconds and looked for crabs. And we literally found enough crabs that if you extend the population numbers that we found, there's hundreds of thousands, millions of king crabs on the Antarctic slope. And the danger is, if they get up to the shelf, they're going to enter a community that really is ill-prepared for crushing predators and could have a big impact on the ecology. Now you might say to yourself, well, you have a crab fishery too. You know, I had an email from an Arctic fisherman. When can I head south? I want to take my crabber to Antarctica. You ever seen that show, the most dangerous catch, or what's it called? The deadliest catch. If you saw the drake in its fury, you would have the deadliest deadly catch. Yes, it would be. I don't know about a crab fishery. All right, and I also want to briefly mention one other important thing that is the other CO2 problem, the one that we rarely hear about. And that's the fact that when we put carbon dioxide into the atmosphere, over 30% of it ends up in the ocean. And it's not benign. There's a series of chemical reactions that's essentially raising the level of acidity of our oceans. The oceans have been, the pH has dropped about 1/10 of a pH unit since the Industrial Revolution. Now that doesn't sound much, but that's a log scale. It's a 30% increase in the acidity. By the end of the century, it may be a 150% increase. Already organisms are being impacted. And Antarctica is the canary in the coal mine. You have thin-shelled organisms to begin with. You have cold water. Carbon dioxide is more soluble in cold water. It's going to be one of the first areas impacted. And so actually, Chuck Emser and I also have an NSF program now that's looking at the effects of ocean acidification on calcified Antarctic invertebrates to study the impacts of this phenomenon. And here are some of the organisms that we're studying in our work. We're using limpets as a model and a gastropod as a model, and also looking at algae, because Chuck is a phycologist. He's interested in calcified algae, algae that makes a calcium carbonate skeleton, and how it's impacted by ocean acidification. Hello. Okay, so here's a sort of a laundry list of what's happening. You have glacial recession, ice sheets that are breaking up. The pack ice is receding along the peninsula. Movement, populations of animals that are tied to the sea ice are having trouble. They're moving or disappearing. The plankton communities are being affected. The plant communities, potentially. Larval development, extending ranges of species, possible invasion of king crabs, and now you have ocean acidification. It's quite a remarkable dynamic story. And this is what the system looks like, or looked like, maybe as little as 50 years ago. You had the annual sea ice forming every year, a nice platform of ice. The Adelie is happily using that ice to get out to the krill that they fed on. You've got the Antarctic circumpolar current feeding the system with nutrients, a rich benthic invertebrate fauna, lots of krill in the water. And what's happening now is probably by mid-century is what's predicted. There will be regions of the Antarctic Peninsula that don't have any sea ice anymore. And the Adelie will be gone from those regions. Not all Antarctica, but from these regions. The Gentoo and chinstrap will have moved in. The salps will be common. There'll be very little krill. Possibly these king crabs may have moved into the system. And again, this is all being fueled by this huge Antarctic circumpolar current. So it's a very dramatic change. Now changes occur, of course, they always have. But what makes this so different is the rapidity of the change. This is happening so fast that some organisms don't have enough genetic wiggle room to adjust, to acclimate, perhaps to adapt to these changes. And that's what makes it so fundamentally different than past changes, which happen over millennia. So why care? One reason is there's cures to human diseases out there in that biodiversity. That's a huge genetic bank that's sitting on the seafloor of Antarctica. It represents 30 million years of evolution. The chemical evolution is amazing. We found all sorts of chemicals in our chemical ecology program that have the potential to become human drugs, including one that's being looked at as a cure or a treatment for melanoma skin cancer right now. So I would argue that the loss of that biodiversity comes at a cost, and that we should think about that. Besides just the aesthetics of a community that's being altered so dramatically. So this is where I always turn to this question that is such an interesting question. I used to get asked when I gave my presentations if it was warming. Is it really warming? I don't get asked that anymore. I can't remember the last time somebody asked me, is our planet warming? That one, it doesn't seem to happen. But now it's turned to, is this just a natural perturbation, or do we have something to do with it? Okay. Well, I'm an objective scientist, so I have to be convinced that there's an anthropogenic fingerprint to all this, so I go to the web. And there's plenty of evidence of global warming on the web. Plenty. You can find it anywhere you go. No, actually, this is what I found. This is what convinced me. We're still in Antarctica. It's perfect, okay? We're going down through 3,600 meters of ice with an ice core. The ice core comes up. It's about this big around, and it's in meter chunks, 3,600 of them. Trapped in the ice is a history of our atmosphere over the last 420,000 years. All you have to do is analyze those little bubbles, and you can figure out how much carbon dioxide was in the atmosphere, and using oxygen isotope ratios, you can figure out the temperature at the time. So you can plot in the red line CO2 concentrations over 400,000 years and temperature variations, and you can see that there's these very predictable peaks. About every 100,000 years it gets warmer and then colder. But what I want you to look at in here is the level of CO2. Right around 300,000 is the peak over the last almost 500,000 years, okay? But then look what happens over on the far right over here since the Industrial Revolution. There has been a 24% increase in carbon dioxide in our atmosphere in this brief little period of time. And what that convinced me is that you really can't ignore that. I mean, that is so fundamentally different than what's happened over all this time. And this has been extended back another 500,000 years now. So if you believe that carbon dioxide is a greenhouse gas, and I don't run into people who challenge that, you have to think that there's an anthropogenic component to what we're seeing in terms of warming. And this explains that 100,000 years cycle. It has to do with the elliptical orbit of the Earth around the sun that drives that 100,000 year cycle of warming and cooling. All right, so can't end with gloom and doom. Let me give you a vision of hope, okay? And this is wonderful because it's also in Antarctica. It all fits together so nicely. In 1985, two British scientists received some more data from their technicians in Antarctica that would suggest that there was a massive hole in the ozone over Antarctica. So like any self-respecting scientists, they said, buy another spectrophotometer. It's got to be wrong. It can't possibly exist. So they bought another spectrophotometer. They went to another place in Antarctica, and lo and behold, they came back with the same data. So they said, we're going to have to publish this after all. And they published in Nature in 1985, probably the most poignant discovery, environmental discovery of that century. The fact that there was this massive hole in the ozone over Antarctica. I mean, remember, this is India and China. And not only that, but the hole would periodically sort of extend up towards New Zealand, areas where there were people. Now, the remarkable thing to me is that within 2 years of that discovery, 2 years, there were over 30 countries, I think it was 50 actually, that met in Montreal, Canada, sat down around a table and decided they had to do something about this. And what they did is they passed the Montreal Protocol that prevented the release of CFCs, refrigerants, into the atmosphere so that we could begin to get a handle on this hole. And that actually worked. Susan Solomon, who was here, who is the chemist that discovered the chemistry behind this hole, she was here as an Ireland lecturer 7 or 8 years ago. I've stayed in touch with her. She told me that now the hole has stopped growing and that they think by the end of the century it may actually close because so many countries, there's now I think 191 countries that have come on board as signatories to the treaty. So it really is working. Kopiana said that he thought that this was the most poignant example of a global treaty working that has ever happened. Now, of course, it's a huge leap from regulating refrigerants to regulating carbon dioxide. I mean, that is a huge leap. But this does illustrate that a global level issue related to climate, in a sense, because believe it or not, the hole in the ozone affects the climate of Antarctica as well, actually can be addressed in a global fashion. All right, so this is the last paragraph of my book. Now, a decade after my first visit to the abandoned station site, I clamber up and over the boulders, dodge the dive-bombing skuas, and take a circuitous route around several fur seals. A short climb takes me to the summit of Emser Island, named for Chuck and Maggie Emsler, across the street here. Below me, a small island called Elephant Rocks bustles with a breeding colony of barking elephant seals, the product of a range extension from the warmer subantarctic. Torgeson Island, which is almost within earshot, is oddly quiet. Its former Adelie colonies in large part permanently abandoned. To the west, the tongue of the Mar Glacier that had so recently extended seaward, covering Emser Island, has dissipated, its final vestiges melting rapidly to reveal nothing but dirt and rock. As I descend from the summit, I pause to gaze into the distance at the cluster of deep blue, tan-roofed buildings that make up Palmer Station. What sort of a world, I wonder, will future generations of Antarctic scientists find when they come to this remarkable place? And when they gaze over this landscape, will they be reminded how this place, this peninsula, these ecosystems serve as a wake-up call to jumpstart the technological, societal, and political paths to a sustainable planet? And that's the end of my talk, and I guess we have time for discussion. Okay. All right, so what I'm making the point here is that if you look over here, you see this red line? It goes all the way up the right axis to right here. 393 parts per million, okay? So that's a 25% increase in carbon dioxide. And this is since the Industrial Revolution.
No, I didn't see that.
Yeah. And that's
right jammed up against the axis. Yeah. I didn't see
and we owe a tremendous credit to this fellow Keeling, I think is his name. He, gosh, maybe 60 years ago, established a sampling station for atmospheric carbon dioxide on top of Mauna Loa on the Big Island of Hawaii. And his data has been absolutely priceless in documenting these atmospheric increases in CO2. And it's ironic because he could never get a grant to fund it. He was struggling. Nobody would fund his research because it was monitoring, it was boring. And now it's just this most amazing, important bit of data that we have. Other questions? Nobody wants to know what it's like to dive under the water? Get attacked? You want to know what it's like to get attacked by a leopard seal? Yeah.
Tell us about being attacked by a leopard seal.
Okay. So we have to deal with leopard seals all the time because around Palmer Station they're quite abundant. And when we go out in our Zodiacs to dive, we're very cautious because leopard seals are very territorial. They're very aggressive towards people. There has been one fatality of a leopard seal that came up and took a female graduate student from the surface down 300 feet, and she died. It was at the British station. I think it was a mistake on the part of the seal. It was an unusual situation where she was not scuba diving. She was snorkeling at the surface, and the seal probably looked up and thought she was a seal, and they eat seals. So we're very careful. We have a leopard seal recall device in the boat. Mom is getting nervous here. Don't worry, we're very safe. This is the mother of one of my doctoral students that works in Antarctica, who's visiting from Seattle. She's fine. I think, so when we see a leopard seal, we drop the siren in, we turn it on, and the divers come right up together, and we get them out of the water, just to be careful. But I'll tell you my encounter with a leopard seal. It was one of my first dives at McMurdo Station, which is the Los Angeles of Antarctic stations. There's 1,000 Americans there. But we were up at the ice edge on a beautiful day, and we were going to dive off the ice edge. And we had all our gear stacked up next to us and everything, and had our suits on, and we're about ready to dive, and a leopard seal came zooming up and threw its head up on the ice against the sea ice and just grinned at us. You know, just 10 foot long, tremendous teeth. They have a head like a serpent, a huge head proportionally to their body, evil yellow eyes. So we looked at each other and said, we can't dive here. I mean, we've been told don't dive around these guys. But the seal disappeared. It just swam, we saw it swim off. So we decided we'd carry all of our gear up the coast a ways to a new site. So we tremendous effort to get out of our suits, drag everything up the coast. So my dive buddy, Ron, he was sitting on the ice edge now, ready to go back in. He had his feet dangling in the water with his fins on, reaching for his mask. And the leopard seal came right up between his legs, and just right there. And so I have a picture. I actually had the sense to I had my camera in my hand. I took a picture, and it shows the leopard seal sitting there, and there's no Ron, because he's doing like 2 backflips with all of his gear on. And so, you know, the seal was under the ice the whole time we were walking along, which is what they do. They stay under the ice, wait for the penguins to jump off and hit them, attack them or something. So, but the seal had come up, so I suspect it was curious. It wasn't going to attack anybody. But we did not test that hypothesis. We did not. Yeah. All right, somebody else. Ted?
Yeah. Why is the ice on the east side of Antarctica not melting?
That's a great question. The conventional response to that is a couple things. One, it has to do with the circulation patterns of the ocean, the Antarctic circumpolar current in that region. Another, the wind patterns apparently play into keeping it colder. There's some speculation, and I don't like this one, that possibly as the ozone hole closes, it could release whatever has been keeping the eastern portion of Antarctica from warming and begin to warm that region, which I hope is wrong. Just to give you a sense, if the western portion of Antarctica was to melt, the ice on top of the land, it would raise sea level 10 feet. Okay. If the eastern portion was to melt, it would raise sea level 150 feet. Okay. So you've got 2 to 3 miles of ice on that entire eastern portion. The good news is you don't have to worry about that. I just don't see, even in the long run, that level of thing happening. But anyway, it's a lot of ice. Yeah.
How much would you see sea level possibly rise?
Well, the IPCC in 2007, when was the last, was that right? I think they predicted about 0.4 of a meter by the end of the century, something like that was sort of the high end. You know, they had kind of a range. So I wouldn't be surprised if they come back with something maybe twice that. And you don't think that's much, but there are already low-lying islands in the South Pacific that have had to be evacuated because of sea level rise by people that live on them. Florida, you know, don't buy real estate on the coast of, don't buy anything on the west side of Dauphin Island. So, now it's going to become more and more of an issue, particularly with storms that come in, making areas more vulnerable. It's interesting because the timing of my book, I think, is good because people are becoming more curious about climate change now than they were before. I won't say that there's a lot of action about doing much about it in our country, unlike some other countries. But I think the fact over the last couple of years, people have a relative who's been through a drought or has been through a tremendous fire or has, you know, had friends whose crops have withered and they've had to get out of the farming business. People are starting to sense that maybe none of these individual events can be attributed to climate change, but maybe collectively there is some sort of a pattern here, and that maybe we should listen. You know, 10 years ago, I would get invited to talk to the Sierra Club or Audubon. Now I'm talking to Rotary. I'm talking to, you know, I've seen that shift. People are definitely more interested in learning about this because of the implications. Ted?
As the United States signed that treaty, the climate treaty, the other nations of the world signed, they have not signed.
There was something signed at the most recent, sort of by 2020, we will start some progress towards some goal, and there's been a lot of discussion about we shouldn't allow the temperature of the planet as a whole to climb more than 2 degrees, which a lot of climate scientists feel that we've probably already surpassed that point. The trouble with these things is even if you mitigate them, it takes a while to go back the other direction. Ocean acidification is particularly a problem because the amount of carbon dioxide we put in the ocean since the Industrial Revolution would take us over 1,000 years to remediate itself, to go backwards because of the chemistry. Apparently it's much easier to get carbon dioxide into the ocean than it is to get it out. So there's big consequences. Yeah.
So you said you'd say something about E.O. Wilson and his involvement.
Oh yeah, sure. So this is great. When I was a young professor here at UAB, I've been here 25 years, we had this wonderful, we still do, this Ireland Award. And so it occurred to me that E.O. Wilson would be a wonderful person to nominate. So I did. But what nobody told me is that if you nominate somebody, you have to host their visit. So I had to take care of E.O. Wilson for like 5 days. And I had to pick him up at his hotel in the morning. We had to go out to lunch together. I mean, I'll never forget the Dean of Medicine and I having lunch at some little barbecue. And E.O. was drawing ants on his sloppy little napkin. And we were looking at each other like, I want that napkin. And the Dean got the napkin. But he felt, this is Jim Pittman. He's a friend of mine. But Jim finally mailed the napkin to me. I think he felt guilty about it. So anyway, the long story short is that we became friends. And he kind of took me under his wing. And we kept in touch. And I visited him at Harvard. And when he came down to give talks, I'd go talk to him. And then when I wanted to write a book, I thought, who better to ask about writing a book than somebody who writes them, like E.O. And he said, yeah, you should do that. That's great. We need people. Scientists need to do more of this. You know, it's important. So I don't know how to write a book. He said, well, you have to have an agent. Well, how do you get an agent? I mean, there's a catch-22 in all this, right? So the next thing I know, he had written a letter or made a phone call to his literary agency, and they looked at my book proposal and said, okay, we'll take a chance. And the rest, you know, followed from there. So really, when I gave E.O. the first book I signed at the club a few weeks ago, when he spoke up there for the humanities presentation, I wrote in the cover, you know, you opened the door. You did it. And he said, you know, you have to stay in Alabama. We need people in Alabama that can talk about climate change and they need to hear this down here. So I'll come down and help you. So as he's getting older, he feels this tremendous affinity, I think, to Alabama, where he grew up. And he wants to spend more time down here. So in your thinking, as you think, you know, of things that you might want him involved in, I think we've kind of got him in our court to come down and interact with us. Anything else?
Jim, you said you would tell people when you're signing.
Oh yeah, I do have a book signing coming up on the 5th of October. It's a Friday at 5 o'clock at the Alabama Booksmith in Homewood. So, or you can go across the street and buy a book at Barnes & Noble's and come by my office and I'll sign it. Or put it in my mailbox in the biology office and I'll sign it. So, and leave it with the front desk. So feel free. I mean, yeah. Thank you.